Welcome back. Today we'll be talking about methods. Before we get started, do read the chapter in our textbook to get better context on what we'll be discussing. So before we get started, let's review what we know. We know statements. You also know conditional constructs such as if, else, and switch statements. You know looping constructs such as the while loop or the for loop. But sometimes that is not enough to avoid repetition in your code. And methods are exactly what help us do that. They allow us to define a piece of reusable code. With that, they support what is called modular programming, allowing us to define our program in modules that can be reused to avoid repetition. So the format of a method is as follows. What you will start with are certain modifiers. Then you will have a return data type, a method name, some parameters, and the body within curly braces. So let's look at a real example. So here's a method for computing the max of two numbers, right? So the first two words here I'll call modifiers, public static. So for now, I sort of put those away and just take them as magic values, and we'll get to what exactly they mean later in the course. Next is int, which is the data type that this method returns. So when you call this method, the value that is returned by it is of type integer. Max is the name of the method, and it takes in two parameters. It takes in two pieces of data. Both are of type int, right? So we've learned two new vocabulary words. One is modifiers, which are here public and static. And second is parameters, which are the values that are passed in. Now the name of the method along with the list of parameters is what is called signature, another term that you need to know. The signatures have to be unique. So you cannot have another method in this program that has the same name and the same two parameters of type int. So let's see what this method does, right? So in the body of the method, you are declaring a variable called result, and you're initializing it to one of the values that is passed in. Right? Then you are comparing the two values. If num1 is greater than num2, then you set the result variable to be num1. Otherwise, you set the result variable to be num2. It's essentially calculating the max of those two numbers. And then there is this new statement here which says return the variable result. So when this method is called, it is doing this computation and returning this value of type int. Right? So let's see how this would be used. Calling a method is called method invocation, right? So in a program, we could use this method as follows. We could declare a variable called I. You can initialize it to max of 2 and 3. So here the values 2 and 3 are being passed into the method. And they're referred to as arguments. These are the actual values that are passed in, whereas in the definition, it's called parameters that come into the method. So argument versus parameters. Parameters are used in the definition, and arguments are the actual values that are passed in. So what will happen here is that the two values will go into max. Max will compute the maximum, which will be 3. And what will be returned is an integer with a value 3, and then it can be assigned to I. Do watch this video. It has a working example of methods and will give you a lot more hands-on experience. So far we've seen that methods typically return a value, right? They give a value back. But sometimes you don't really want the method to return a value. You just want the method to do some computations or print something and then stop, right? So in these cases, you can just specify a method with a return type of void. That means the method is not returning anything, right? So in this example, we want to pass in a string, which is a name, and all we want the method to do is print hello followed by the name, right? We don't want it really to return any value, right? So here you don't have to have a return statement, or if you did want to return through some conditional logic because of some reason, then you could always call return semicolon explicitly, right? So when you call a method, when you use a method, the arguments that you are providing to it are passed by value. That means a copy is made of that data, and the copy is what is passed in. So let's explore that with an example. Here we have a class with a main method, and we have defined an additional method called increment, which does not return anything. It takes a single argument, a single parameter that is of type int, and it's called n. Within the method, it is incrementing n and just printing its value, right? The main method is initializing a variable x to 1, printing x, passing x into the increment method. And you notice when you pass in, when it goes in, it'll be incremented. And then when the increment is over, printing it, the value of x. So let's see what it would print. So what it would print is, obviously, when it first prints it, it'll have the value 1. Then it calls increment, and the execution goes in here. The value 1 has been passed in. It gets incremented to 2. And the 2 gets printed next. Lastly, you have the original x gets printed. Since a copy was passed in, the original x hasn't changed. So x remains 1, and that is what gets printed. Now, Java allows us to define several methods with the same name. So for example, you could have a method max that takes 2 integers, a method max that takes 2 doubles, and a method max that takes 3 doubles, right? All 3 can coexist. The only catch is that the signatures, the term we defined earlier, of the 3 methods have to be different. So just to remind you, a signature is made up of the name of the method and the list of parameters, which is basically the number of parameters and the types of parameters. So the signature of this method is made up of max and 2 integers. This one is max and 2 doubles, so obviously it's different from this one. And this one's is still called max, but it's got 3 doubles, so a different set of parameters. So it is different from the above 2. So all these 3 can coexist, right? Now the interesting thing here is that we have a very similar definition as we did earlier for this one. The definition here stays the same. There's nothing different you have to do for a double. And here we are leveraging the previous method to define this new max method for that takes in 3 doubles. So we basically call max with the first 2 numbers, and it will return the max of these 2 numbers. And then we call max again with the 3rd number, right? So it's perfectly possible to nest these invocations. Now there is a pitfall with using methods, and that's called ambiguous invocation. So that is when the compiler cannot figure out which method to use. So let's take an example. So here we have the same method max that now takes an integer and a double. And we have defined another max that takes a double and an integer. Now these have different signatures because the list of parameters is different. In the first case, the first one is an int and the second is a double, and it's the other way around for the second one. Now, if in our program we were to call max1, 2, the compiler would not be able to figure out, were we referring to this one or were we referring to this one, and will most likely throw an error. So new term, ambiguous invocation, that means when the compiler cannot figure out which of multiple overloaded methods that we are referring to. So the last concept I would like to talk about is scope of variables, right? So a scope of a variable is essentially the part of the program where the variable can be used, right? Where the variable has meaning. So let's illustrate that with an example. So let's use a new method called myMethod that is defined as such. In the body, you have a couple of statements, couple of variable declarations, and you also have a for loop with 2 embedded statements, right? So let's look at these variables one at a time. So you have a couple of variables in here. You have I that is passed in as a parameter. You have a variable j that has been declared here. Then you have the loop variable k that is declared in the for loop. So now I can be used through the whole method. I has meaning through the whole method. Whereas j can only be used s2 onwards. You could not refer to j within the statement s1 because it's only been declared here. It doesn't have meaning before that. Now the variable k only has meaning within the body, right? Outside of the for loop, either after or before it, it does not have any meaning. It cannot be used, right? We also sometimes refer to a variable that can be used within a particular method as a local variable. The variable I is local to the method and cannot be used outside of the method. All right, that is all, and I'll see you next time.